This is Lesson 5, the end of Chapter 1. We're talking about absolute value today, and we've already said earlier that absolute value is the distance that some number is from 0 on the number line. And when you write the absolute value as a piecewise defined function, we say the absolute value of a number is just the number if that number is 0 or greater. But it's also the absolute value of a number is the opposite of that number, and that occurs if the number is negative. Then extraneous solutions, that's when you have a solution from the original equation that cannot work in the original equation. Here's an example of that. If we say the absolute value of 2x minus 1 is 3 times that number, and you take the number 2x minus 1 and solve it for the positive answer, or you take that number 2x minus 1 and solve it for the opposite of that number, this case here will give you 5x equals 1, so x equals 1/5. This is a good answer. But this case here, this one, gives you an extraneous solution. When you solve negative x equals 1, x can't be negative 1. This is called extraneous, because if we put a negative number here, the absolute value, by our definition above, this is never negative. So we call this extraneous. Let's look symbolically at definitions here. The absolute value of a number is a. We know that's the distance from our number a to 0 on the number line. So in this first example, either our answer is positive a or it's the opposite of a. So x is either the opposite of a or it's a itself. In the second one, the absolute value of x is less than a. That's the distance between x to 0, and it's less than a unit. So it's going to be in between. We call this a conjunction. So it's the solution in between. Either x is greater than the opposite of a, and x is less than a. This is an and statement. We called that a conjunction. And then the last example, x absolute value of x is greater than a. This is an or statement. It's a disjunction. So the arrows and the solutions are going to go to the right infinitely or to the left infinitely from a. So either x is less than negative a or x is greater than a. So let's jump in with solving some of these. Solve the equation, the absolute value of x minus 6 is equal to 2. So x is either going to be 8, or we're going to say the opposite of our number x minus 6 is 2. So x minus 6, I'm going to divide the negative on both sides. So x is equal to 4. So we have two solutions. Either x is 4 or x is 8. In this example, the absolute value of negative 5x, that would be 5 times x is 20, or the opposite of the absolute value of negative 5x is 20. So if 5x is 20, x is 4, and if the opposite of the opposite of 5x, that would be 5x is negative 20, because I'm dividing this negative on both sides, then x is negative 4. So in our example, either x is negative 4 from this solution, or x is positive 4 from this solution. In part C, 3x plus 2 absolute value is going to be either that number, 3x plus 2, or it's going to be the opposite of that number, 3x plus 2. And you can tell each time I'm dividing through by this negative, so at 3x plus 2 equals negative 4. And here, 3x plus 2 equals 4, so x is 2/3, or x is negative 2 when we solve for x in this particular case. So either x is negative 2, or here's 2/3, x is 2/3. And then lastly, I want to get rid of the 3, so 2 times the absolute value of x plus 9 is equal to 7 minus 3, which is 4. Divide by 2 on both sides, and we want to solve for x plus 9, and we want to solve for the opposite of x plus 9. So I'm taking that negative and dividing the negative over here. So solving for x in both equations, we're going to get x is negative 7 from this solution, or x is negative 11 from this solution. If we call this tick mark negative 11, then this tick mark would be negative 7. Here we want to investigate some absolute value that have extraneous solutions, possibly. In the first example, if we have 3 times the positive value x minus 8, we have 3x minus 24 is x minus 9. So 2x is equal to 15, and x is 7.5. So let's think about this. If you have 3 times the absolute value of some number here, and it's going to equal 7.5 minus 9, you notice how this side is going to be a negative number? Well, we can't have 3 times a positive number equaling a negative number, so 7.5 would be called extraneous. But we've only investigated the positive number here. So we want to go back and look at the negative value. So what would the negative or the opposite of our left side be? In this case, if we have negative 3x plus 24 is x minus 9, and we get the x's alone, negative 4x is equal to negative 33, then x is 8.25. So once again, I'm going back up here to this area. If we put 8.25 and subtract 9, this right side is equal to a negative number. And 3 times a positive number will never be a negative number. So in this case, we also have extraneous. And example A has no solutions to that equation. There will be no number where 3 times the absolute value of x minus 8 would be the number x minus 9. So this has no solution. How about letter B? If we divide both sides by 2, then the absolute value of x plus 7 is going to be 6, or the absolute value of x plus 7 is going to be the opposite of 6. So the answer would be negative 1 or negative 13. And when you go back to check, let's just real quickly check. By putting a negative 1 here or a negative 13 here, we want to verify we get 12. So 2 times the absolute value of 6 is definitely 12. This one works. And 2 times the absolute value of negative 6 is also positive 12. We have 2 valid solutions. In part C, we're going to solve for 5x minus 2 is equal to 7x plus 14. So isolating the x, we get negative 2x equals 16. X is negative 8. And we want to do the opposite. So 5x minus 2, we want the opposite of that number, is 7x plus 14, which makes negative 5x plus 2, 7x plus 14. Collecting like terms, we have negative 12x equals 12, so x is negative 1. Now we want to check both of these answers. So here again, you can see our dilemma. When we put negative 8 over here, we have negative 56, add 14. This right side is going to be negative, and the left side is not negative, which makes negative 8 extraneous. This one is extraneous. But if we put negative 1 here, 14 minus 7 will give us a positive number, and negative 5 minus 2, the absolute value of negative 7 is positive 7. That equals positive 7, so we have one solution, just negative 1. In example 3, we want to solve and graph the solution to this inequality. Now you notice it's in the form of the absolute value of x is less than or equal to a number. That's an and statement. So we're solving either 3x minus 4 is less than or equal to 8, or we're solving 3x minus 4 is greater than or equal to negative 8. And the reason I say this is because we did the opposite of 3x minus 4 is less than 8. If you divide on an inequality by a negative number, you flip the inequality and make your answer negative. So I went straight to that approach right here. This is how we came up with this. Okay, so solving 3x minus 4 is less than or equal to 8. We have x is less than or equal to 4. And solving the second piece, 3x minus 4 is greater than or equal to negative 8. So 3x is greater than or equal to negative 4. And x is greater than or equal to 4/3. So we want a conjunction here. And if this is 4, and 3, 2, 1, this is 0, this is negative 1, so right about here we have negative 4/3, negative 4/3, right about there. And either x is less than or equal to 4, or greater than or equal to negative 4/3. We have that conjunction where they overlap. Let's look at part B. Now notice in part B, this one is also a conjunction. It's the less than or equal to, so we have either the number 7 minus x is less than or equal to 3. Let me get my blue pen here. 7 minus x is less than or equal to 3, or the opposite of 7 minus x is less than or equal to 3. So we said this is an and statement, since its absolute value is less than or equal to a number. So here we have negative x is less than or equal to negative 4. Divide by negative 1, flips our inequality, and x is greater than 4. So we'll call this 4 here. And then this one, if we divide by negative 1, or we can multiply through, that would be okay. Then x is less than or equal to 10. So we have 4. We'll call this 10 up here. 4, 6, 8, 10. Well, this would be 10 here. So 4 to 10. If we count by twos, and x is greater than 4 or less than 10. So we could also write that solution set this way. 4 is less than or equal to x is less than or equal to 10. And then finally in part C, we're looking at 1/4 of the absolute value of x minus 3 plus 2 is less than 1. So again, this is an AND statement. And we're going to subtract 2. So we got -1. So let's multiply by 4. This should be x minus 3. Multiplying by 4, x is less than -1. So we're going to check that answer. And then working for the opposite of our x minus 3, we want the opposite of that is less than 1. So again, multiplying by -4 flips the inequality, and x is greater than 7, so we want to check that. We again said this is an AND statement since it's in the form absolute value of x is less than a, so we would expect a conjunction. And if this is -1 here, and we just called this one 7, x is less than 1, less than -1 goes this way, and x is greater than 7 goes this way, and we know they're supposed to overlap. This makes an OR statement. This is an OR statement. And this part in here would be our AND statement. So these answers do not work, and we have no solution set since our intervals do not overlap. So lastly, in example 4, do you see the difference in this example? We have the absolute value of x is greater than a number. This is an OR statement. So solving for 5x plus 10 is greater than 15. 5x is greater than 5. X is greater than 1. Or the opposite of 5x plus 10 is greater than 15. So 5x plus 10 has to be less than -15, and 5x would be less than -25, so x is less than -5. So will these work in our OR statement? If x is greater than 1 and less than -5, that would be a disjunction, so greater than 1 and less than -5. That definitely has a solution set. We could also write that solution from -infinity to -5 and from +1 to infinity. So we could write it as a solution set that way. Now, can you explain without graphing what you know about the equation absolute value of x minus 3 is greater than or equal to 2? Describe the graph of its solution set. So turn off the video and write a solution, a sentence, what you know about the solution set, and then come back to check your answer against my answer. And I said something like this. This statement is a disjunction. It's an OR statement. So the inequality graph will include 2 points, and the shaded regions will extend to the left and to the right infinitely because it's an OR statement. Hopefully you understood the graph that way as well. In the last 4 examples, we're going to write compound inequalities as absolute value inequalities. But first we have to find the average, the middle, or the mean, and we have to find the deviation. So to find the middle or the average, we want to add up the endpoints 1.6 and 2.1 and take the average of that, which gives us the middle value. And then to find the deviation, we want to take the difference between those values, 2.1 and 1.6, and take the average of that. So 2.1 minus 1.6 divided by 2 is going to be 1/4. That's our deviation. So the way to write the inequality is to say the absolute value of x minus our middle term, 1.85, has got to be less than or equal to a quarter. And we knew that because this original statement was written like a conjunction. It's an and statement. So give letter B a try and then come back to meet me when you're finished. I found the average to be 140 plus 230 divided by 2. I found the middle to be at 185. And I found the deviation between the difference, 230 minus 140 divided by 2, to be 45. It's also an and statement. So we know that the absolute value of x minus 185 is less than or equal to 45, but I'm not paying attention. My variable was p, so we want to change that x and make that variable p. So the absolute value is written in that format for our inequality here. Okay, in part example 6, this time they're giving us the picture, so we're going to work backwards. In this case, it looks like this is 3. So we want to find the middle. 3 plus negative 4 divided by 2 would put our middle at negative a half. This is the middle. And the deviation would be the difference. So 3 minus negative 4 divided by 2 would put us at 3.5 for our deviation. So it's similar to example 5. We're just working from the graph now and not from the number statement. So the absolute value of x minus negative a half, and it's also an and statement. We can tell by looking at the picture. This one's an or statement, so this one is an and statement. And an and statement is the format absolute value of x is less than a, so we're less than the deviation. Where this one over here in example B, we're going to have the absolute value of x is greater than or equal to a, since our values are colored in. So the middle is our x bar. The middle looks like it's 7. 10 minus 4 divided by 2. So that's going to give us 7. And the deviation is going to be, I said 10 minus 4. It should be 10 plus 4 divided by 2. And the deviation is 10 minus 4 divided by 2. That's going to put us at 3 for the deviation. So we have the absolute value of x minus the middle is greater than or equal to the deviation. So we went 3 in either direction. And to finish the lesson, we have 2 real-world examples. A meteorologist predicted the 4th of July temperature would be within 4 degrees of 92. So they're telling us what our deviation is, 4 degrees. So 4 degrees to the left or 4 degrees to the right. This is our middle. 92 is the middle. To write that as a prediction, the degree, D represents the degree. The middle is 92, so the absolute value of D minus 92, and it's going to be within 4 degrees. So we got to be within 4 degrees, would be less than or equal to 4. And finally, example 8, carpenters take their morning break no earlier than 10 a.m. and no later than 11:30 a.m. We want to let B represent the time the workers take their break. So if we add 10 plus 11:30 and divide it by 2, that's 10 3/4 for the middle. And the deviation is 11.5 minus 10 divided by 2. That's 3/4 of an hour for our deviation. And I'm going to let the letter B stand for break. So we want to have an and statement again. we want to include, so the break minus the middle would be less than or equal to 3/4 of an hour. And we have finished Chapter 1, Lesson 5.